Okay, class, today we're going to talk about direct variation. The reason why we're talking about this is because the standard that we're working with right now is 8.5a, and it says that we have to be able to represent linear proportional situations with tables, graphs, and equations in the form of y is equal to kx. So what we're really focusing on today is this y is equal to kx. Okay? So what is direct variation? Well, for direct variation, two variable quantities are related proportionally by a constant positive ratio. The ratio is called the constant of proportionality. Well, some other words that we use to represent constant of proportionality are constant of variation, rate of change, unit rate, several different things that we've talked about in class. But what it all boils down to is, what's the slope? Okay, our constant of proportionality, or our k value, is nothing but the slope, and I'll demonstrate that when we get to one of our example problems. It says the graph of a direct variation equation is always linear and always contains the point 0, 0. So that's the same definition that it takes for a relation to be proportional. Is it must make a line, which is linear, and it must contain 0, 0. In other words, we have a y-intercept of 0. So the variables x and y either increase together or they decrease together. In other words, they vary directly. So we're going to work some problems that look something like this. So the key phrase that we're looking at when we deal with direct variation is y varies directly as x. Now what that really means is that as our x value changes, so will our y value, and it will change proportionately. Okay, so how are we going to work these problems? Well, there's a four-step process that I want you to follow to solve these kind of questions. Okay, and the first step that we're going to go through is write the formula. And the direct variation formula that we're going to use is y is equal to kx. Okay, where our x and our y, well, they're our typical values, and our k is with our x. Now, so that k, it's the same thing as what we've used in the past as an m, which represents slope. Okay? So the second thing that we're going to do is we're going to solve for k. So we need to find k. Well, how do I do that? Well, we do that by plug in the x and y that we know. So it says, suppose y varies directly as x. If y is 3, or y equals 3 when x equals 15, then find x when y is equal to 5. So the x and y that I know are right there. Okay? So it's going to be two pairs, basically. We've got a pair that I do know, my x and my y, if y is 3 when x is 15. So they go together. Those are the two values I'm going to plug into my equation to find k. So I'm going to take this y is equal to 3, and I'm going to substitute y. We'll substitute a 3 for that. Equals, well, I'm looking for k, so I leave k alone, times, because when I put the k and the x together, that means multiply. And I know my x value is 15, so I'm going to put a 15 there. Now what I do is solve for k. So here I have a multiply by 15. Well, how do I get rid of that? I do a divide by 15. And if I do that on one side, I must do that on the other. So that tells me that k is equal to one of two things. Either I simplify 3 over 15, which simplifies to 1 over 5, or I type that in on the calculator and I get 0.2 as an answer. Either one is perfectly acceptable. Okay, now the third thing I have to do then is solve for the unknown. Okay, solve for the unknown. What is it that I'm looking for? Well, in this particular case, that's going to be in the second x and y. So it says find x when y is equal to 5. So the next thing, solve for the unknown. How do I do that? Well, I write the formula down again. So I start with my formula. I write that down. So y is equal to kx. And now, how do I solve that using that formula? I plug in what I know now. Okay? Plug in values. So we're going to plug in the values. Okay, well, what values do I know? Well, in the second one, I know another y value. Okay, so I use the first y and x, or x and y, to find k. Now I use the second one to find the unknown. So I know y is 5, so I'm going to substitute in my 5 for the y. But now I also know k. K is 0.2. And now I'm looking for x because it says find x. So now, how do I get the x by itself? Divide by 0.2, divide by 0.2, and I end up with x equaling, well, if you type in 5 divided by 0.2 on your calculator, you end up with 25 as your value. Now, I told you this all relates back to our t-charts, and it reverts back to slope, because k, in essence, is just slope. So let's see what we know so far. Okay, well, let's put it in relation to a t-chart. Well, in the t-chart, I have x and y values, and I have an x and y in our problem. So it says that x is 15, or when x is 15, y is 3. Well, what I just found out, or what I wanted to know is, okay, well, what is x when y is 5? Okay, so when y is 5, what is my x value? Well, we just found out that our x value is 25. So hopefully you kind of see that there's kind of a relation there. So we could, now that I know 15 and 3 and I know 25 and 5, what if I said the y value of 4? What would my x value be? Well, based on those patterns, it looks like 4 would be, my x value would be 20. Or now what if I told you that the x was 30? What would my y value be? Well, based on what we have there in our t-chart, we know it would be 6. Now I told you this k was just like our slope. Well, how did we find slope when we had a t-chart? We did our pattern on the right-hand side divided by the pattern on the left-hand side. Well, what is our pattern on the right-hand side? 1. What is my pattern on the left-hand side? 5. Isn't that the same thing I came up with as my value for k? It tells us that in direct variation, when we find k from that point that I know, when I find that proportional relationship, all I'm finding is my slope. Because we know k, based on this, k is equal to y divided by x. Or as we dealt with slope earlier, m was equal to delta y divided by delta x. It all means the same thing. So let's see if we can work a second question. Okay, this time we won't write all the steps down. We'll just reference the steps. So step number 1 is you write your formula down. So y is equal to kx. So the problem says, suppose y varies directly as x. Find x when y is equal to 10, if y is equal to -7 when x is equal to -14. So we look for the two that we know. Well, I know y is equal to -7 when x is equal to -14. So those are the values that I'm going to use. So I take my y value, -7. I substitute it in for y. Equals, I'm looking for k, so I leave k as an unknown. And I know my x is -14. Okay, so I need to get the k by itself, so I divide by -14, divide the other side by -14, and we end up with those 14s going away, and we're left with k equals, well, -7 divided by -14 gives me 0.5, or 1/2, okay, either one. Okay, so now I'm going to use that k value, and the y is equal to 10 to find the x. So I write my formula down again. Y is equal to kx. Well, this time it says find x when y is 10. So I'm going to use this 10 value as my y. I now know k is 1/2 or 0.5. So I plug that in and I'm looking for x. And now we solve for x. So I divide by 0.5, divide this side by 0.5 as well. So my 0.5s cancel out and x is equal to, well, 10 divided by 0.5 gives you 20. Okay, and that's how we do direct variation. So let's have you do one, and then I'll come behind you and work it. So pause the video and work this problem. Okay, let's see how you did. It says, suppose y varies directly as x. If x is equal to 15 when y is equal to 12, find x when y is equal to 21. Okay, so step number 1, write the formula. Step number 2, solve for k. So it says if x is 15, y is 12, so there's my x and y that I'm going to use. So I plug the 12 in for y. I'm looking for k. I plug the 15 in for the x. Divide both sides by 15. K is equal to And when you type in 12 divided by 15, you get 0.8. Okay, so now I write the formula down again. Okay, and it says find x, that's my unknown, when y is 21. So I substitute in my value, my y value for y, 21 equals. Well, I know 0.8 is my k, and I'm looking for x. So I divide by 0.8, I divide by 0.8, and x is equal to, and I believe this one, let me get my calculator real fast. I forgot the answer on this one. So you get 21 divided by 0.8, and you end up with 26.25. So not all the time are the answers nice, pretty numbers. Sometimes you will get decimals in there. All right? Now I got one more unique kind of question to look at before we end the video. So what about this one? It says, suppose y varies directly as x. If x is 24 when y is 10, then what is the constant of variation? Well, what is constant of variation? What is that again? That is the k value. So in this particular problem, all I'm looking for is what is k? So we substitute in our values. Y is equal to 8. I'm looking for k, and my x is 24. So I divide both sides by 24, and k is equal to, we have 8 divided by 24. Well, that gives us kind of an ugly answer of 0.3 repeating. And we know we cannot use a repeating decimal as a fraction or as an answer. So we know k is then equal to, well, the fraction that gives us 0.3 with a bar is 1/3. So we have a k value, or a constant of variation value, of 1/3. Or constant of variation is just the slope. That's all it amounts to. So that's how we work constant of variation or direct variation problems. I hope this helps. Until next time.